Alright, so the next thing we're learning is solving logarithmic equations. So far you've learned to evaluate them, we've condensed them, we've expanded them, and now we're going to solve them. So we have three types of equations we're going to look at here. And the first one you see, type 1, is when I have an exponential equation that I require a log in order to solve it. So we have three steps for these equations. The first one is to get the base with the exponent alone. The next one is to take the log of both sides. Remember, I need the base of the log to match the base of the exponential equation in order for it to cancel each other out or become 1. And then I'm going to solve. Remember, solve means to get the variable alone. So we're going to go ahead and try number 2 using these steps. So the first thing I need to do is I need to get the exponent alone, the base with the exponent. So I'm going to move this 10 over to the other side of the equation. And leaves me with 16 negative 7x equal to 92. I then need to take the log of both sides. So I'm going to take log base 16 of 16. Remember, we want it to match. And then the exponent negative 7x equal to 92. Now, if you remember back to our expanding and condensing our properties of logs, we know this exponent we can move to the front. And I know log base 16 of 16 is just 1. So what I'm left with in this side of the equation is negative 7x times 1. Well, it's 1 times anything is the anything. So we just have our negative 7x left on this side equal to 92. Our goal here is to solve. We're trying to get that variable alone. Oops, didn't mean to do that. Our goal is to get that variable alone. So we are going to divide by negative 7 on both sides of the equation. And x is equal to 92 over 7, and the 7 is negative, so our equation is negative. All right, so let's look at number 3. Again, I need to get the logarithm by itself. So I'm going to divide both sides by negative 3, which leaves me with 4m plus 10 equal to 25. And now I need to take the log with the base of 4 of both sides. So I have log base 4 of 4 to the m plus 10 equal to log base 4 of 25. This side I know I'm left with just that m plus 10. So I have m plus 10 equal to log base 4 of 25. I don't know what the log base 4 of 25 is, so I just leave that how it is. I need the m by itself, so I'm going to subtract 10 from both sides. And this is what m is equal to. We cannot combine 25 and negative 10 because they're not like terms. This 25 is log base 4 of 25, which we know is not 25. So I need to leave my answer like that. All right. You should now pause the video and try number 4 and 5 on your own, and then play it to check your answers. All right, so hopefully for number 4, you got x equals log base 15 of 5 minus 3. Remember, this minus 3 is not the same thing as 5. Those are not like terms, so they have to stay separate. Remember, you had to get your part with the exponent by itself first. That's how we end up with 5 here and not negative 3. On number 5, remember, I needed to move the 1 with the 3, so I got 2. And my negative 4k here, this is multiplication. It's negative sign, but it's multiplication, so I need to divide by it. Again, this 2 and this 4 are not like terms, so they just stay that answer. All right, now type 2 log equations. Here are my steps for the type 2. This is where a log equation is equal to a log equation. So I make sure each side of the exponent with a base that matches your log. Then the inverse operations will undo each other. So just like up here, we used logs to undo the exponential equation. I'm going to use an exponent to undo the logarithmic equation. Then I'm going to solve, or I'm going to get the variable by itself. So I have my first equation here. As you see, they both have a base 3. So I need to make these the exponents. So I'm just going to write the 3's here and move my equal sign down. So now it's 3 raised to 3 to the log base 3 of 3x plus 3 equals to 3 to log base 3, 5x minus 5. This part is going to simplify to 1, so this goes away. This is going to simplify to 1. And from our rules, we know what we have here, I can just bring out to the front. So I end up with 3x plus 3 equals 5x minus 5. So I subtract 3 from both sides, and you don't have to move the 3 first. It's just what I chose to do. gives me 3x equal to 5x minus 8. I now need to subtract 5x. 3x minus 5x is negative 2x, which is equal to negative 8. Let me scroll down a little bit. I then need to divide by negative 2. So x is equal to 4. So for number 7, our x is 4. And I need to give myself a little bit more space here. Alright, now that we have some more room, let's try number 8. Again, I need to make these equations the exponent with a matching, a base of a matching as this base. So I'm going to have 19. And I'm going to raise it to log base 19 negative 2x equals 19 raised to log base 19 of negative 3x minus 9. Again, this part's going to simplify out to 1, and that's going to leave me with just negative 2x equal to negative 3x minus 9. And I no longer need this parentheses because I got rid of what was being distributed into it. So I'm going to get the x by itself. There's already an x over here alone, so I'm just going to move this x over. So it's plus 3x plus 3x. Negative 2 plus 3 is just x equal to negative 9. The x is by itself, so we're done with that one. Now I need you to pause the video and try 9 and 10 by yourself and make sure you get the right answer. Alright, hopefully you had a chance to get these problems. Let's see if you got it right. So I raised both these to an exponent with a base of 19. This part simplifies to 1. So I'm left with 4r plus 5 equal to 3r plus 9. I need to get my r, my variable, by itself. So I'm going to move the 3r over. 4r minus 3r is just r plus 5 equal to 9. I now need to subtract this 5 from both sides. I'm going to move it over here. R equals 9 minus 5 is 4. Hopefully that's what you got for number 9. Number 10, you should have used 12. So here I have 12 to the exponent of log base 12 negative n equals 12 raised to log base 12 of 2. This part's going to simplify to 1, so I'm left with negative n equals to 2. This is almost by itself, but it has this negative sign here. So remember, we can't have a negative sign at the end, so I need to divide by negative 1. And n equals negative 2. Alright, moving on. Our last kind here. Here we have a basic log equation. So our steps here are to get the log on one side by itself, just like our first type. We make both sides an exponent with a base that matches the log. That's like our second type. Then the inverse operations will undo each other and we solve. So the first thing I need to do is get this log equation by itself. So I have to divide by 3. So I get log base 2 m minus 10 equals 1. 3 divided by 3 is 1. I'm now making both of these the exponents like we did in type 2. But I need to use this base. So I have 2 raised to the log base 2 of m minus 10 equal to 2 raised to 1. Well, I know these are going to undo themselves, so they're just going to be left with m minus 10 equals, and I know 2 to the 1. 2 to the 1 is just 2. Remember, anything raised to the 1 is just itself. I can now get m by itself, so I add 10 to both sides, and m equals 12. Let's try another one of these. Number 13. Here I have a negative 1, but notice there's a plus sign here. So it's being added, but because it's a negative, it's really being a negative number added, which means I have to add it over to this side. If you were to subtract it, negative 1 minus 1 would give me a negative 2, and I need it to equal 0. So on this side, I have log base 2 m minus 6 equal to 3. Remember, I now need to make exponents like we did in type 2, or exponential equations with this as the base. So I'm raising both of those. 2 to the log base 2 of m minus 6 and 2 to the third, or 2 cubed. So this side, these are going to undo themselves. So I get m minus 6. Over here, 2 to the third. Remember, that just means 3 2's multiplied together. So 2 times 2 is 4. 4 times 2 is 8. If you don't know those, you can type them into your calculator. And then we add 6 to both sides. So m equals 14. All right, now you need to pause the video and see if you can do the last two on your own, and then play the video again to check your answers. So, all right, hopefully you had a chance to solve these two. Let's try 14. Let's see if you got the right answer. We're going to subtract 1 from both sides. Remember, I need to get the equation, the logarithmic equation alone. 1 minus 1 is 0. That part's good. I'm left with log base 9 x minus 3 equal to 2 minus 1 is just 1. I now need an exponential equation matching this base, so I raise that with a 9, so it's 9 raised to the log base 9 x minus 3, and 9 to the 1. Over here, we know those undo themselves, so it's x minus 3 equal to 9 to the 1 is just 9. I add 3 to both sides. X equals 9 plus 3 is 12. Number 15. We need to divide by 3 because there is no sign here in the middle. That means it's multiplication. And to undo multiplication, we use division. These cancel out to 1. So I'm left with log base 4 n plus 1 equal to 6 divided by 3 is 2. I now need to make this an exponent matching this base. So I need 4. Remember, my bases have to match. That means I need 4 squared on this side. These are going to undo themselves, so I get n plus 1 equals 4 squared, which we know is just 16. I subtract 1 from both sides. N equals 15. Hopefully you were able to get those two questions right. If you have any questions, make sure you contact your teacher so you can get more help, and then go ahead and try the practice.